Welcome back, students, to the video lecture series of EGDL. Today we are going to take up a new topic, projection of straight lines. As soon as we enter projection of straight lines, your movement is restricted only to first quadrant. This is very important. Okay. In other words, we are going to follow first angle projection from now onwards. You know what is first angle projection? The front wall is treated as VP and the ground is treated as HP. And your reference line will be represented like this from now onwards. X, Y, VP and HP. We were not writing VP and HP when we did problems on projection of points, because we discussed the position of a point in all the four quadrants in projection of points. As soon as you enter projection of straight lines, you are going to follow first angle projection. In other words, the line is going to be there in first quadrant only. Okay, so when it is in first quadrant, you know what is its position. If there is a line in first quadrant, what is its position with reference to VP and HP? It is in front of VP and above HP. So this is fixed now. The line is going to be in front of VP always, and it is going to be above HP. So in front of VP means the top view is going to lie below XY. And above HP means the front view is going to lie above XY. So this is fixed now. Let me repeat once again. When you have a line in first quadrant, it means that the line is above HP and it is in front of VP. When I say in front of VP, the top view should be below XY. And when I say above HP, the front view has to be above XY. So in first angle or in first angle projection, the top view will always lie below XY and the front view will always lie above XY. This is going to be fixed from now onwards. Projection of points, planes, solids and all. Okay. Now having understood that, what is that we are going to do in the introduction? I am just giving an introduction to projection of straight lines. What we are going to do? We are going to find three things for a given position of line. I am going to show you various positions of a line with reference to VP and HP. We will restrict our discussion once again only to VP and HP. Let us not involve the profile planes right now. RPP and LPP will not be involved now. So for a given position of a line, you are going to find these three things. One is true length of the line. What do you mean by true length? It is the actual length. Okay. Then the second is true inclinations of a line with HP and VP. If you consider this to be a line, let us say this is a line. When I say line, it is unidimensional. It has got only length. Okay. That means the thickness is neglected. The thickness of the line is neglected. Okay. So it is unidimensional. When we discuss the projection of points, point has no dimension. It is dimensionless. Now, as soon as we enter projection of straight lines, it has got length, unidimension. Okay. No breadth, no thickness. They are neglected. So for the given line, you will find the true length as the first case. In the second case, you will find its inclination with HP and VP. Inclination of the line with HP is denoted by theta and inclination of the line with VP is denoted by phi. It is a standard. They are standards. And then we will also find the traces. We call them as horizontal trace, shortly HT, and vertical trace VT. So I will take different positions of a line in space and find out these three for each position. Okay. So I'll write them shortly. What I am going to find. Let me erase this. what you are going to find? The first thing is true length, Tn. The second is you will find theta and phi. Theta is inclination of the line with HP, phi is inclination of the line with Vp. And then you will also find HT and VT, horizontal trace and vertical trace. Now let me take the first position of the line. I'll call it as position 1. What is position 1? Line parallel to both HP and VP. This is the first position of the line, position 1. Now let me show that position to you. If you consider this to be a line, okay, I am keeping the line in this position. Is the line parallel to HP? Yes, it is. How do you say that? When this end and this end of the line are at the same distance from HP, I can say the line is parallel to HP. In fact, they are at the same distance from HP. Similarly, is the line parallel to VP? Yes, of course. This end of the line and this end of the line, they are at the same distance from VP, so I can say it is parallel to VP. So, in fact, the line is parallel to both HP and VP here. Now, let me obtain its projections. Okay. If I want its top view, I will project it onto the ground. I get a line there. Similarly, if I want its front view, I project it onto the wall, front wall. Here also I will get a line. Now, what is the position of these two lines with reference to XY line? They are parallel to XY line. Okay. So this 3D scenario, if I convert into 2D, how do you draw them? This is your XY line. First angle projection, so VP and HP. As I said, the top view is going to be below XY line now, the front view will be above XY line. So, let us say this is A, top view of A, this is A dash, front view of A. Now this is the top view of the line, I will draw it parallel to XY. This is the top view of B, and then this is B dash. This is front view of the line AB. I have taken the line as AB, that means I have taken this end as A and this end as B. Now I have projected the line onto the ground and also onto the front wall. Then the ground is imagined to be rotated and brought into the plane of the VP, vertical plane. This is what you see. Okay. So when I draw the top view here, is it equal to the actual length of the line? When I project it on the ground, is it equal to the actual length of the line? Yes, in fact. Okay. Both the top view and the front view, both will be in their true lengths or the actual length of the line. We call them as true lengths here. Instead of saying actual length, we call it as true length. So in this case, both the top view and front view are true lengths. So I will just write here some length, let me take. True length is equal to 40. So the front view is true length, the top view is also true length in this case, when the line is parallel to both HP and VP. So the first thing is done, true length is done. Now let us come to the inclinations. What is theta? Inclination of the line with HP. Now I have kept it parallel to HP. So what is its inclination with HP? It is 0, or you can say it is 180 degrees. Okay. Similarly, it is parallel to VP, so I can say the angle phi is also 0 or 180. So I will write them here. 1, both front view and top view are true length. That is the first statement. Second, theta is equal to 0 or 180. Similarly, phi is equal to 0 or 180 degrees. Done. Because the line is parallel to HP and also VP. Now, what is this? What is HT and what is VT? First of all, what is trace of a line? Basically, the trace of a line is a point. What is that point? Let us say the line is inclined to, I am taking a different position. Let us say the line is inclined to HP like this. The line is inclined to the horizontal plane. Imagine that the line is extended. The line is extended to intersect the horizontal plane. That point is what is called as horizontal trace of this line. Okay? So when the line is imagined to be extended, the point where the extended line intersects the horizontal plane is called as horizontal trace of this line. Similarly, if you imagine the line is inclined to VP like this, imagine that this line is extended to meet the vertical plane at some point. That point is called as the vertical trace of this line. Okay? So having understood what are the traces for this position of the line, can you tell me where HT and VT lie? When I extend this, it doesn't intersect either HP or VP. Okay? So I can say the traces are at infinity. Both horizontal trace and vertical trace are at infinity because the line doesn't intersect HP or VP. So I can write here, third statement, HT and VT are at infinity. In other words, they don't exist. This position of the line will not have HT or VT. Okay? So this is about the first position of the line. Okay? The line parallel to both HP and VP. Here I will give you an important statement which we call as true length principle. What is that? Let me show it here. The true length principle is like this. When the top view of a line is parallel to XY, then its front view is true length. Let me repeat again. What is the statement? If the top view of a line is parallel to XY line, then its projection is true length. That means the front view is true length. Similarly, if the front view of a line is parallel to XY line, then its top view is true length. Both the statements are called true length principles. Okay? Please write it down in your notebook. Okay? I'll repeat again. If the top view of a line is parallel to XY line, then its front view is true length. Similarly, if the front view of a line is parallel to XY line, then its top view is true length. I'll write the statement here, you can copy it down. It's called as true length principle. TL principle. If the top view of a line is parallel to XY line, then its front view is true length. Okay. Similarly, if the front view of a line is parallel to XY line, then its top view is true length. Very important principle in projection of straight lines. You will be using this principle in every problem of straight lines. Okay, so it's very, very important. Let me repeat again. If the top view is parallel to XY, then its projection is true length. This may not be true, but this is true. Similarly, if this is parallel to XY line, this is true. Since both are parallel to XY line, both are true lengths here. Okay. So this is about the first position of the line. We take it as position 1. Having understood this, let me move to the position number 2. Position 2, here I take a line inclined to HP and perpendicular to VP. This is the second position of the line. Let me show it to you. This is the position I started with. The line is parallel to both HP and VP. I'm sorry, should be inclined to HP and parallel to VP. I started with the line parallel to both HP and VP. Now I want to keep it parallel to VP, but I want to make it inclined to HP. How do you do that? Rotate it like this. Or you can rotate it like this. See, the line is made inclined to HP. But is the line parallel to VP? If you want to check, what you have to do, measure the distance of this end and this end from vertical plane. They should be at the same distance. If they are at the same distance from VP, then you can say the line is parallel to VP. Yes. In this position, both the ends will be at the same distance from VP. This line. Okay, let us obtain the projections of the line now. Imagine that the line is projected onto HP. You get a line on the ground, and that line will be parallel to XY line, is it not? Because the line is kept parallel to VP, when you project it, you get a line on the ground which is parallel to XY line. But is that line equal to the true length of the line? No. The top view of the line is no more true length now. We call it as apparent length. It is reduced in length. We call it as apparent length. So you got the top view parallel to XY line and its length is apparent. Let us check the front view now. Imagine that the line is projected onto the front wall. What is its position with reference to XY line? It is inclined to XY line, and also you will find that the front view is true length here. It will be equal to the actual length of the line. So what is the position of the front view? It is inclined to XY line and true length. And what about top view? It is parallel to XY line and apparent. Let me show it here. Let us take this as XY line. The front view should be inclined and true length. This is front view A dash, B dash, projector, parallel. So this distance can be any distance. Similarly, this distance also you can take any distance. Okay. This is true length. Let me take it as once again 40 mm. Let us say this angle is some 30 degrees. This is the top view, A, B. Okay. So this is how you represent position number 2. The line is inclined to HP and parallel to VP. In this case, only the front view is true length, the top view is apparent length. Okay. So I can write my first statement as front view is true length, top view is apparent length. to the inclinations theta and phi. What is the inclination of the line with HP? 30 degrees. Just an example you have taken. Theta is equal to 30 degrees. What about phi? Can you tell me what is the inclination of the line with VP? It's parallel to VP. So phi has to be 0 or 180. Yes. Let us come to the traces part now. Now, will this line has horizontal trace? Will it have horizontal trace? Yes. The line is inclined to HP, so this will have horizontal trace. When I extend it, it will go and intersect the ground or the HP at some point. So that is called horizontal trace. But will it have vertical trace? No. It will not have vertical trace because extension this way or this way, it doesn't intersect VP at all. Okay, so VT is at infinity, but it will have HT. How to find HT? In space, that is how you get HT. When you extend it, the point of intersection with HP is HT. But how do you find it on the drawing sheet or on the board? This is the procedure. What you have to do is extend the front U to intersect the XY line at some point. You can call it a small HT. At that point, you will draw a line perpendicular to XY. Then extend the top U. Wherever they intersect, that is your horizontal trace. So when you draw this on your sketchbook, you can draw it as a rough sketch, no dimensions required, just to understand the principles. This has to be thick. This line is thick. This line is also thick. Okay. This extension line should be light line. Perpendicular is also light line. This extension line is also light line. But of course, this point can be shown dark. Horizontal trace. So this is the horizontal trace of the line in 2D scenario. Okay. And I can show the directions also for your reference. This is how you proceeded. Proceeded down. Proceeded from right to left. So this is about the second HT. It will have HT. HT you are showing here. VT is at infinity. So you can copy down in your sketchbook. You can pause your video and copy it down. Okay. This is about position number 2. So these things you are not going to practice using your software. This is only an introduction. Okay. The problems that you practice using your software will be are under drawing number 3 that we will be taking up later. But before that, we will be discussing 5 positions of the line, this being the second. I hope it is understood. Now let me take up position number 3. Now let me recollect that true length principle once again. Let us see whether it is satisfied or not here. Here the top view of the line is parallel to XY line, therefore the front view is true. So the true length principle is satisfied here. Putting it in the other way, I can also make the statement like this. If the front view of a line is true length, then the top view is parallel to XY line. So vice versa of the statement. Okay. What is it? If the top view of a line is parallel to XY, then its front view is true length. Or if the front view of a line is true length, then its top view is parallel to XY. You can pause your video and write down the statement, whatever I have told just now. Okay. Done. So we are done with position number 2. Let us move to position number 3. Position number 3, I still will keep the line parallel to VP only, but I will make the line perpendicular to HP. Line perpendicular to HP and parallel to VP. So the parallel to VP is being continued. First, second and third, all the 3 positions, the line was kept parallel to VP. But with reference to HP, I am changing its position. Let me show it in space once again. This is the first position. The line is parallel to both HP and VP. Then I made it inclined to HP, making sure that the line is kept parallel to VP. This was second position. Now I am still rotating it and I am making it perpendicular to HP. So what is the position of this line? It is perpendicular to HP, but it is parallel to VP. This end and this end are at the same distance from VP. Now let us obtain its positions. What will be its top view? When you project it, it is just a point, is it not? The top view of this line is a point. What about the front view? The front view is perpendicular to XY and true length. Okay? The front view is perpendicular to XY and true length, and the top view of the line is a point. Okay? Let me show it here. XY line, VP, HP. Front view is perpendicular and true length, A dash, B dash. Top view is a point. AB is the straight line. Let us take the true length once again as 40. True length is 40 and this is the point, top view. Now here one important point. You are taking the top end as A, the bottom end as B. Now if you want to get its top view, the position of the observer is imagined to be on top. We are following first angle projection. So what is the order? Observer, object and plane of projection is the order. The object should come in between. Now the end A is nearer to observer and the observer will be able to view end A. And end B is exactly below A. So the observer will not be able to view end B. It just appears to be a point and only point A is visible to the observer. B is invisible. That's the reason why B is kept in brackets here. When a point is kept in brackets, it is understood that it is invisible to the observer. Okay? Here is the observer. The observer, object, plane of projection. So A is visible to observer, B is invisible. B is kept in brackets. Now, this distance you can take any distance, B to XY line, and from here to here it could be any distance. So in this case, which view is true length? Only the front view is true length. The top view is a point. So I will write here, front view is true length, top view is a point. This point is called as the limiting position of line. That is the limiting position of the line. Okay. Then what are theta and phi? Theta is equal to 90 degrees, as you see there. The front view is perpendicular, the line is perpendicular. And phi is once again 0 or 180 because the line is parallel to VP. Coming to the traces, will this line have HT? Yes, it will have HT because when I extend it, it meets the ground at some point. Where does it meet? It will exactly meet wherever you have the top view. In other words, in this case, the projection of the line and extension of the line are the same. Okay? When the line is like this, extension is like this, projection is like this. So they are different. But in this case, the projection and extension are the same. So the HT and the top view coincides. Okay. So if I show on the board here, or if I adopt the procedure that I have mentioned already, what is the procedure to get HT? Extend the front view to meet XY line to intersect XY line at small HT. Then at small HT you will draw a perpendicular. That perpendicular will go and intersect the top view here, so that itself is HT. In other words, the HT and top view coincides. And where is VT? VT is at infinity because the line is parallel to VP. So I can write here VT, vertical trace, is at infinity. Now here I can give the true length principle in an interesting way. What is the true length principle? If the front view of a line is perpendicular and true length, then its top view is a point. This is also a very important principle. Let me repeat again. If the front view of a line, this is the front view of the line, when it is perpendicular to xy and true length, both should be satisfied, then its top view is a point. Or putting it in the other way, if the top view of a line is a point, then its front view is perpendicular and true length. Okay, please write down the statement in your sketchbook. Okay, if the front view of a line is perpendicular and true length, then its top view is a point. Or vice versa. If the top view of a line is a point, then its front view is perpendicular and true. Please write down the statement in your sketchbook. So this is about position number 3. Not 2, it is 3. So when you draw it on your sketchbook, you must make sure that only this portion of the line is dark till here. This should be light. Only then again this point can be shown dark. XY line is a light line. Okay, the dimension line is also light line. And when you are drawing this projector, if this is your graph sheet that you have, okay, so draw this line coinciding with the line that you have here. Better that way. Okay. Even your XY line also you coincide with the line on the graph sheet. Okay, let us take position number 4 now. Position number 4, line is inclined to VP and parallel to HP. Okay. If you recollect, in the first 3 positions I kept the line parallel to VP. But here I made the line inclined to VP. Of course, it is made parallel to HP. So can you see its position in space? This was the first position, just going back once again, position number 1. Then I made the line inclined to HP and kept it parallel to VP. Third position, I made it perpendicular to HP and it is parallel to VP. So if you closely watch this, I am rotating this line in a plane parallel to VP. Okay. This rotation is happening in a plane parallel to VP. If you can imagine this plane of rotation, the plane of rotation is parallel to VP. Now what do? I have to keep it parallel to HP. And I have to rotate it in a plane parallel to HP. So like this. So that it is made inclined to VP. Either I can rotate like this or I can rotate like this. You should rotate it in a plane parallel to HP. So this position, the line is inclined to VP. Line is inclined to VP and parallel to HP. So in this position, if you draw the top view, What is its position with reference to xy? It is inclined to xy, but it is true length. Its top view is inclined to xy and true length. What about front view? When you project it on the front wall, it will be parallel to xy because it is parallel to HP. The front view you will get parallel to xy and it is apparent length. It's not true length. Okay, so the top view is going to be true length and inclined to xy. The front view will be apparent length and parallel to xy. So let me show it here. The top view is going to be inclined and true length. So I'm showing it like this. Some inclination you can take. This is top view. So I'll write it as AB. Whereas I should make the front view parallel to XY. This is important. So this is A dash, B dash. Let us say this angle, you have to represent it by phi, some 45 degrees. And also this is true length. Let us say 40. So the front view is true length, top view is apparent length here. So let me write down the same thing here. Front view is true length, top view is apparent length. Now the second one, theta is equal to 0 or 180, phi is equal to 45 degrees. Some angle, you can take some angle. Now this line will have VT. Because the line is inclined to VP, it will have VT. Where do you get VT? Just extend this line to intersect XY line at small VT. There you drop a perpendicular. Extend the front view. Wherever it intersects the perpendicular, that will be VT. Same procedure like what you did for HT. Okay? What did you do? Extend this line. It should, you have to extend this. Wherever it intersects XY line, mark a point there. Drop a perpendicular there. Then extend the front view of the line. Wherever they intersect, you get VT. That is VT. Then HT is at infinity. There is no HT for this line because the line is parallel to HP. And you can see the true length principle here. Because the top view is true length, the front view is parallel to XY. In other words, if the front view of the line is parallel to XY, its top view has to be true length. You can put it in any way you like. That's about the true length principle. So this is about position number 4. Okay. Now the last position or fifth position, position 5, before we close this video. What should be position 5? Line should be made perpendicular to VP. Okay, I'll make this perpendicular. Line perpendicular to VP and parallel to HP. So can you imagine how the top and front views of this line come? This is how you have the line. The line is perpendicular to VP, it's like this. And it is parallel to HP. Okay, it was, first position is like this. Now you are rotating it in a plane which is parallel to HP. You have taken this as position 4, it is inclined to VP and parallel to HP. Now I made it perpendicular to VP and parallel to HP. So what will be top view? It's perpendicular to XY line and true length. And what will be front view? What will be front view? It's just a point. Okay. So top view is perpendicular and true length. This is top view, perpendicular and true length. Let's say this is A and this is B. Front view is just a point. So which point should I keep in brackets? A. I should keep in brackets because this is the position of the observer. B is visible to observer, A is invisible. So A invisible, B is visible. Okay. This is true length. Let us say 40. This should be front view, A dash, B dash. So my statement, top view is true length, front view is apparent length. Theta is equal to 0 or 180, phi is equal to 90. 3. This will not have HT. HT is at infinity. And it will have VT. This is small VT. This is the vertical trace VT. Okay. So this is about the introduction to projection of straight lines. We have discussed 5 positions. In all the 5 positions, the line was kept parallel to either HP or VP. Is it not? In the first 3 positions, I kept the line parallel to VP. And I made it either parallel to HP, inclined to HP, or perpendicular to HP. Then in the next 2 positions, I kept the line parallel to HP. Okay. So either the line was kept parallel to HP or VP in all the 5 positions. What if you have the line inclined to both HP and VP? That is the last position or 6th position. Normally the problems are asked on that position only. So whatever I have told you now, you just can have them in your sketchbook for your reference, but you don't have to submit them. Okay, no submission required for these things. This is just an introduction. When we move on to drawing number 4, projection of straight lines, those problems will be under the line inclined to both HP and VP. So those problems you will be solving and submitting. And these things, no submission is required. But these are important. These are important for you to understand the ultimate position or the final position. So with this, I'll close this video. I'll come back for the next video later. See you.